Good morning. Today we are going to do amines and diazonium salt in one shot. Whole NCERT topics are there, and at the same time cover in-text questions. Okay. So the amines, chief commercial use of amine is as an intermediate in the synthesis of medicines and fibers. Fibers role is increasing day by day. So, if commercial use of amines as and intermediates in the synthesis of medicines and fibers. And in organic, what we do, let us say we have hydrocarbon. So we will replace hydrogen of the ammonia by alkyl or aryl group. Like we have ammonia, so if we replace one of the hydrogen and add alkyl in it, come amine, aliphatic amine. If we remove hydrogen and add aryl group, then we get aromatic amine, aniline. Okay. So in nature they occur among proteins, vitamins, alkaloids, and hormones. So synthetic examples include polymers, dyestuffs, drugs, and two biologically active compounds, namely adrenaline and ephedrine. Adrenaline, that is used in mood changing, and both containing secondary amino group and are used to increase the blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in dentistry. Benadryl, a well-known antihistaminic drug, also contains tertiary amino group. And quaternary ammonium salts, they are used as surfactants. We will study in chemistry in everyday life chapter about it. And diazonium salts, they are intermediate in the preparation of a variety of aromatic compounds, including dyes. Because if NH2 group is on benzene ring, then it is very difficult to break this CN bond. Why is it so? Because CN bond acquire double bond character. So to remove this NH2 group, first we convert NH2 into diazonium salt, because diazonium salts are very good leaving. Okay, amines. So amines are considered as derivative of ammonia. So in ammonia, if we remove one hydrogen and add alkyl group, get this product, and this is called primary amine. If only one hydrogen is replaced by alkyl group, that is primary amine. If we remove hydrogen and add C6H5, that is aniline, and this is also a primary amine, but this is primary aliphatic amine. If alkyl groups are there, that is called aliphatic amine, and if there is a aryl group, that is called aromatic amine. So aromatic primary amine, aromatic secondary amine. If ammonia, two hydrogens of ammonia are replaced by two methyl groups or two alkyl groups, any alkyl groups, then it is called secondary amine. And if all the three hydrogens of ammonia are replaced by methyl groups, then it is called, or any alkyl group, that is called tertiary amine. So primary amine, when only one hydrogen of ammonia is replaced by alkyl or aryl. Secondary amine, if two hydrogens are replaced by alkyl or aryl. And tertiary amine, if all the three hydrogens are replaced by alkyl or aryl group. Now, structure of amine. In structure, nitrogen is attached to three alkyl or aryl groups. See, nitrogen, if we see its electronic configuration, it is 2s2, 2p3. 2s2, 2p3. So 3 2p and 1 2s, they overlap to form sp3 hybrid orbitals, in which one of the sp3 hybrid orbital contains lone pair and other three has one unpaired electron that overlap with alkyl groups, and that's why orbital of the alkyl group, and therefore they form tetrahedral arrangement with its lone pair on the apex, and that's why it has pyramidal shape. It has pyramidal shape. Angle is less than tetrahedral because of presence of lone pair. The lone pair repel the bond pairs, and that's why angle is around 108 degree. And hybridization is sp. Classification, I have already told you that ammonia, when replaced by one alkyl group, it is primary amine. If it is replaced by two alkyl groups are added in place of hydrogen, that is secondary amine. If all the three hydrogens are replaced by alkyl group, that is tertiary amine. In nomenclature, alkane plus amine. So E of alkane is replaced and we get alkanamine. So primary amines are written as alkanamine. See, CH3, CH2, NH2. So it is in common, this is alkyl group, that is ethyl amine. Common name, and it is ethane plus amine, that is ethanamine. Here propane amine, propanamine, or propane 1-amine, because there are two types of carbons, CH3, CH2, CH3. Primary amine, primary carbon, secondary carbon, tertiary carbon. If primary hydrogen is replaced by NH2, that is called normal propylamine. If secondary is replaced, that is called isopropylamine, and it is propane 2-amine, and first one is propane 1-amine. Now come to next. See, very interesting. Reason being, now in between two alkyl groups there is nitrogen. So the one which has more number of carbon is taken as parent chain, and other with the lower number of carbon atom is taken as side chain. That's why it is N-methyl, not 1, 2, 3, because methyl group is attached to nitrogen directly. So it is N-methyl ethanamine. This is ethanamine. What is this? Ethanamine. Now, when one of the hydrogen of NH2 is by methyl, it is N-methyl ethanamine. Okay, N-methyl ethanamine, or it is ethyl amine. Ethyl amine. Next is the three methyl groups, trimethylamine, or it is a derivative of ethanamine. Now, if one of the hydrogen is replaced by methyl, it is called N-methyl methanamine. If one more hydrogen is replaced by methyl, it is NN dimethyl methanamine. Next one. This is the parent chain, that is butane, 1-amine, N-ethyl, N-ethyl means NN diethyl, NN diethyl, butane 1-amine, or NN diethyl butylamine, NN diethyl butylamine. Next part. What is the name of this group? CH2 double bond CH, CH2, called allyl group. So this is allyl amine, or IUPAC name. So it is prop 2-ene, double bond is at position 2, 2-ene and 1-amine. Because when we have double bond as well as functional group, the lowest number is given to functional group. Functional group is NH2 and then double bond. So bond root is prop, double bond, so it is ene and 1-amine. Ene, this E is removed because next is also vowel. Next, CH2 6, NH2, NH2. So CH2 means methylene. Common name of CH2 is methylene. So it is hexamethylene diamine, and IUPAC name. So there are total 6 CH2 and 2 NH2. So 1, 2, 3, 4, 5, 6. So hexane 1,6 diamine. Hexane 1,6 diamine. And what is the name of this compound? This is aniline, or we can say it as benzenamine. Aniline is IUPAC recommended name, or we can say it as benzenamine. Next, 2-methyl aniline, 4-bromoaniline, and common name is orthotoluene and para-bromoaniline. Next is NN dimethyl aniline, NN dimethyl aniline as well as benzenamine. Okay. Now classify the amines as primary, secondary, or tertiary. Tell me first one. First one is it primary, secondary, or tertiary? Yes, beta. First one, is it primary, secondary, or tertiary? Classify them fast. Home. Yes, beta, bolo. Yes, it is primary. Very good. First one is primary because nitrogen is attached to only one group. One of the hydrogen of ammonia is replaced. What about second? It is tertiary because all the hydrogens of ammonia are replaced by alkyl or aryl groups. Yes. Third one. What about third one? Fast. second is tertiary, and third one is again primary. Because nitrogen of ammonia, only one hydrogen is placed, and fourth one is secondary. Primary, tertiary, primary, secondary. Now write the structures of different isomeric amines corresponding to the molecular formula C4H11N. C4H11N. That is derivative of C4H. How many H? C4H9 and H2. That is C4H10. That means CH3, CH2, CH2, CH3, or CH3, CH, CH3, CH3. Normal butane, and this is isobutane. So from normal butane we can get CH3, CH2, CH2, CH2 and H2. This primary amine, or to form primary amines we need to look at only hydrogens, and to get secondary amines we should see carbon-carbon bonds. There are two types of carbon-carbon bonds, CH3, CH2, NH, CH3, sorry, CH2, CH3, CH3, NH, CH2, CH2, CH3. Okay, these are the four amines from primary normal butane. What about isobutane? So see, there are two types of hydrogens, CH3, CH, CH3, CH3. This primary amine, CH3, sixth. Okay. Now carbon-carbon bond. There are only one type of carbon-carbon bonds. So compound formed is these are the primary and secondary amines, 6, 7. Now tertiary amines. Tertiary amine, you know, three groups. So ethyl and two methyls. There is only one tertiary amine. So first one is primary. First is write the IUPAC name. First write the structures of different isomeric amines corresponding to molecular formula. So I think there are total 8 isomeric amines. Now IUPAC name. So what is the name of the first one? It is butane 1 amine, because NH2 is at the position 1. One is butane 2 amine. This one 1, 2, 3. That is 2 methyl propane 1 amine. 2 methyl propane 1 amine, right? What about this? 1, 2, 3. It is 2-methyl propane, amine, to methyl propane, amine. What about this? Parent is this one with more number of carbons. So it is N-methyl propane 1-amine. This one, 1, 2, 3. It is yes, beta. What is the name of this compound? 2-N-methyl propane. Right on the next page. CH3, CH, CH3, NH, CH3. It is N-methyl propane 2-amine. Then it is CH3, CH2, CH3, CH2, and CH3, CH3. What is the name of this compound? Is N, N dimethyl ethanamide. These are the IUPAC names, and just see the isomerism exhibited by different pairs of amines. See, I give you one example, like first and second, butane 1-amine, butane 2-amine. Addition isomers, 2-methyl propane 1-amine, 2-methyl propane 2-amine. Again, position isomers, okay, and methyl propane 1-amine, and methyl propane 2-amine. Again, position isomers is 7th and 8th. So first and second, fifth and sixth. Third and fourth we have not written, right? It is third is the name of the third, and ethyl enamine. So see NH on both sides there are CH3, CH2, CH3, CH2. Okay, so N1 is as a substituent, other is as the parent, and ethyl ethanamine, and this one is N-methyl. Okay, fourth we have written. Okay, first, second, then fifth, sixth, and fourth, seventh. Fourth, seventh, and fifth, sixth. These are addition isomers. Okay. Then come to distribution of alkyl group around nitrogen. So third and fourth, the relation between them. Here, respect to NH, there are ethyl groups. In here, NH, ethyl and propyl. What are they? Distribution is different. What we call them? Yes, beta. They are metamers. But we call them as metamers. So metamers are third, fourth. Then we can see the chain isomers. Okay, so on. So we can predict the isomerism in different pairs of amines. Okay. Next, preparation. Now, first is preparation from nitro compounds. So nitro compounds, in nitro compound there is NO2. So that is reduced to NH2. These oxygens are removed by or replaced by hydrogen. That is reduction, addition of hydrogen and removal of oxygen. So nitro compounds, they are reduced to amines just by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals like tin, iron in the acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. So NO2 changed into NH2 by H2PD in ethanol or SnHCl, FeHCl. But best is Fe and HCl. Why? Because in this case, reduction when takes place with Fe and HCl, FeCl2 is formed, which is reduced back to HCl, and that's why only a small amount of HCl is required to initiate the reaction. See, reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction, and only a small amount of hydrochloric acid is required to initiate the reaction. So keep in mind there are three reagents: H2PD, nickel, platinum, or SnHCl and FeHCl. But best one is FeHCl because in this case FeCl2 is formed, which is hydrolyzed back to get HCl, and therefore small amount of HCl is required. Only scrap iron is used. That is not very costly. Next, ammonolysis of alkyl halides. So when we do ammonolysis of alkyl halide, the lone pair of ammonia, because of the presence of lone pair of ammonia acts as a nucleophile and that will attack on alkyl group. Get ammonium salt, which is treated with sodium hydroxide, and we get primary amine along with NaX and H2. So ultimately we will get primary amine, but if alkyl halide is in excess, if ammonia is in excess, we get primary amine as the major product. But if alkyl halide is in excess, then further reaction takes place. We get secondary amine. Further, it will react to get tertiary amine, and at the end we get quaternary ammonium halide. Get quaternary ammonium salt. See, primary amine with alkyl halide, we get secondary amine, Again alkyl halide we get tertiary amine. Again alkyl halide we get quaternary ammonium salt. So free amine can be obtained from the ammonium salt by treating with a strong base. But this ammonolysis has disadvantage. Reason being, mixture of amines are formed, creating a mixture of primary, secondary, tertiary amines, and also a quaternary ammonium salt. But to get primary amine as the major product, what we use, we take ammonia in large excess, so that whole of the amine, whole of the alkyl halide is converted into ammonium salt. No alkyl halide left unreacted to do the further reaction, and that's why we get primary amine as the major product. Now there is a breaking of CX bond. So which halide is most reactive? Can break easily. So Ri is more reactive than RBr than RCl because of large size of iodine, the order of reactivity. Now write chemical equation for the following reactions. Reaction of ethanolic ammonia with C2H5Cl. C2H5Cl when react with ammonia, first of all we get primary amine. Further reaction takes place, we get secondary amine. Then again reaction taking place with ethyl chloride, so we get tertiary amine, and ultimately we get quaternary ammonium salt. Quaternary ammonium salt. Same ammonolysis of benzyl chloride. What is benzyl chloride? C6H5CH2Cl. Reaction with ammonia, we get Cl is replaced by NH2. Then 2 moles of methyl chloride. Obviously, these are the 2 hydrogens. They are replaced by ethyl. We get N dimethyl benzylamine or N dimethyl phenyl methenamine. Phenyl methenamine. The reactions of Hoffmann ammonolysis. This one, ammonolysis of alkyl halides. Reduction of nitriles. So you know nitrile is C triple bond N. So if hydrogens are added on both sides by replacing those pi bonds, so that is called reduction, and that can be taking place with lithium aluminum hydride or catalytic hydrogenation that produces ammonia H2 nickel, or sodium amalgam in ethanol, that is called Mendes reaction. Sodium amalgam and ethanol called Mendes reaction. Reduction of amide, again CO that is placed by CH2. So that is again in the presence of lithium aluminum hydride and water, and we get primary amine. So lithium aluminum hydride जो है, that is the key reagent to reduce nitrile as well as amide. Gabriel thalamide synthesis. Thalamide we have prepared from phthalic acid. You know, this is phthalic acid. Phthalic acid. So when we treat it with ammonia, we get thalamide on strong heating. So ammonia is removed and we get thalamide. Now this hydrogen of thalamide is highly acidic. because two electron withdrawing groups are attached, and that's why with strong base it gives potassium salt, potassium thalamide. Because acid base reaction takes place, it acts as acid, KOH is a base, acid base reaction, so we get salt and water, potassium thalamide. On treating with alkyl halide, this CX bond breaks, so N is attached to R, N alkyl thalamide. That's why this reaction cannot be given by aniline, because that means primary aromatic amine cannot be prepared by Gabriel thalamide synthesis, because in that case, we need aromatic halide, aryl halide, and you know in aryl halide there is a double bond character. CX bond acquire double bond character, and that's why breaking of CX bond is difficult, that do not take place. That's why we cannot do this reaction with aryl halides. They do not undergo nucleophilic substitution. So we get N-alkyl thalamide, which on alkaline hydrolysis we get sodium salt of thalamide, salicylic acid, and along with RNH2, Rn attached to two hydrogens. So we get primary aliphatic amine. Keep in mind that is very important reaction where we get pure primary aliphatic amine or exclusively primary aliphatic amine. But limitation is primary aromatic amine cannot be prepared by this method. Okay, that is Gabriel thalamide synthesis and very important from examination point of view. Next is Hoffmann bromide degradation. That is also very important. In Hoffmann bromide degradation, CO group is completely removed by Br2 and NaOH. So we get primary amine from primary amide. So it's completely removed. That's why it's called degradation. Decrease in number of carbon atoms. Okay, along with sodium carbonate, NaBr and H2O. This reaction is also very important for conversions, because to decrease number of carbon atoms we use this reaction. Amide can be prepared from acid by reacting with ammonia on heating, or carboxylic acid can be prepared from alcohol by oxidation. Okay, or alkyl halide. Alcohol can be prepared from alkyl halide by using aqueous KOH. So we can convert or we can decrease number of carbon atoms of alkyl halide. We can decrease number of carbon atoms of alcohol. We can decrease number of carbon atoms of carboxylic acid by this reaction, by this route. So we use Hoffmann bromide degradation, and in short it is called HBD reaction. Hoffmann bromide degradation reaction. See, now CH3CH2 Cl, convert it into CH3 CH2 CH2, and means we have to increase number of carbon atoms. To increase carbons, keep in mind we always use NaCN, alcoholic NaCN, and to decrease we use Hoffmann bromide degradation. So Cl is replaced by CN, and on further just reduce it by H2 nickel, sodium amalgam, ethanol or lithium aluminum hydride, we get the product. Next again we increase one carbon, again we use NaCN. We get this product, phenyl, ethane nitrile or benzyl cyanide, and then on reduction we get the product. Write the structures and the IUPAC names of the amide which gets propanamine by Hoffmann bromide reaction. See, propanamine. To get propanamine, CH3, H2, H2, NH2. To get it from amide by Hoffmann bromide degradation or Hoffmann bromide reaction. We know in Hoffmann bromide reaction, CO group is completely removed. So this is the amide, that is butanamide. It is butanamide. Propanamine contains 3 carbons, and amide molecule must contain 4 carbons because one CO is also there. So butanamide, amine produced by Hoffmann bromide by benzamide. So you know benzamide. This is benzamide on Hoffmann bromide degradation, that is with Br2 and NaOH or KOH. So CO is completely removed, eliminated, and we get aniline. So aniline is the main product. So benzamide is an aromatic compound, aromatic amide containing 7 carbon atoms. Obviously, amine so formed is aromatic with 6 carbon atoms. That is aniline or benzamide. How will you convert benzene into aniline? Yes, beta. This is benzene. To convert into aniline is we attach NH2. So to attach NH2, what do we do? First we nitrate it. Nitration. We get nitrobenzene, and then with FeHCl. Just we have done FeHCl or SnHCl. Okay. Or H2PD. Now benzene into N and dimethylaniline. So up to this reaction is same. First we will get aniline by this route, and then further reaction with 2 moles of methyl chloride. Homolysis of amine, ammonia. So we get N and dimethyl aniline. Next is CH2,4 ClCl. So hexane 1,6-diene. That means we increase the number of carbon atoms. So always keep in mind, whenever there is increase in number of carbon atom, we will treat it with NaCN. Both sides there are chlorine. So CN groups are attached on both sides. And then on further reduction, CN is reduced by lithium aluminum hydride. And we get CH2NH2 on both sides. And this way we get hexane 1,6-diamine. Physical properties. So lower aliphatic amines are gases. The order primary amines with 3 or more carbon atoms, they are liquid, and still higher ones are solid. Obviously, when the number of carbon atoms increases, van der Waals attraction increases, and therefore first gases, lower members are gases, then liquids, and then ultimately solids. Aniline and other aryl halides are usually colorless but get colored on storage due to atmospheric oxidation. So lower aliphatic amines are soluble in water because they can form hydrogen bond with water molecules. Solubility decreases with increase in molar mass. Reason being, large hydrophobic part is there, and because of that hydrophobic part, they become insoluble because solubility decreases. out of butane 1 ol and butane 1 amine, which will be more soluble in water and why? So amines are soluble in organic solvents like alcohol, ether, benzene. Alcohols are more polar than amines, and therefore they form stronger bonds, interval hydrogen bonds, than amines. The solubility order is primary, secondary, and then tertiary, because hydrogen bonding is maximum in primary. Primary and secondary means are engaged in intermolecular hydrogen due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. So intermolecular association is more in primary amines than in secondary amine, because there are two hydrogen atoms available for hydrogen bond formation. Tertiary amines do not have intermolecular association because there is no hydrogen atom available. So boiling point as well as solubility, both order is primary, secondary, and then tertiary. The comparison of boiling points. Normal primary amine 350, corresponding same molecular mass secondary amine 329.3, tertiary amine 310. That means primary boiling point of primary is greater than secondary, greater than tertiary. C2H5, okay, hydrocarbon less alcohol is maximum. Is boiling point of primary alcohol is maximum, primary amine is, then secondary amine, then tertiary amine, then alkane, hydrocarbon. Okay, that is the order. Chemical properties. So in amine there is a lone pair, and due to the presence of lone pair, they are basic in nature. And primary amine is aliphatic amines are more basic than aromatic. Reason being, in aliphatic amine, lone pair is easily available from the salt. Aniline, lone pair is less available because lone pair is involved in conjugation, that is involved in resonance. So aliphatic primary amines are more basic than aromatic. And strong base, higher Kb, and lower pKb. Strong base, higher Kb, lower pKb. Yes, beta. Hello. So the methenamine and methyl methenamine and dimethyl methenamine. So see, secondary amines are more basic than primary, than tertiary. For methylamines, this is the order. Secondary is more than primary and then tertiary. In case of ethylamines, again secondary is more basic than tertiary, then primary. You see the order. Hello? Yes, beta. Hello. Beta, in methylamines, order is secondary, primary, tertiary, and in case of ethylamines, it is secondary, tertiary, primary. Keep in mind, in ethylamines, plus I effect is dominating, and in methylamines, H bonding is dominating. See this one. Alkanamines and versus ammonia. So obviously, alkanamines are more basic than ammonia because there is plus I effect, and due to plus I effect, there is more electron releasing groups on primary amine than ammonia. and that's why lone pair is more available for donation. So alkanamines are more basic than ammonia. But when we compare ethylamines and methylamines, the plus I effect of, if we compare in plus I effect is maximum tertiary, then secondary, then primary. So this should be the order of basic strength. But in the steric hindrance, steric hindrance is maximum in tertiary, so it should be like this. And if we compare the H bonding, yes, beta. I said in case of methylamines or ethylamines, aliphatic amines, plus I effect, if plus I effect is the main deciding factor of basic strength, then tertiary is most basic because there are 3 releasing groups. In secondary, there are 2 releasing groups. In primary, there is only 1 releasing group. If we compare steric hindrance and hydrogen bonding, so hydrogen bonding is maximum when H plus is attached. It is maximum in primary, then secondary, then tertiary. Because see, ammonium salt is formed, and hydrogen bonding, more is the hydrogen bonding, more stable is the ammonium ion, and that's why it should be primary, secondary, and tertiary. So plus I effect is dominating in ethylamines. Ethylamines plus I effect is dominating. That's why the secondary is maximum because it is in between. Not favored, not against. Secondary is maximum, and ethyl is bigger in size than ethyl. So plus I effect of ethyl is maximum, and hydrogen bonding is maximum of methyl because of smaller size. That's why in case of ethylamines, it is secondary, then tertiary, primary. In case of methylamine, it is secondary, then primary, tertiary. That is the order of basic strength. In aryl amine ammonia, obviously aryl amines are more basic. Sorry, aryl amines are weaker base because lone pair is involved in conjugation. So nitrogen get a positive charge in most of the resonating structures. So lone pair is less available for donation in aromatic amines, and only 2 resonating structures are possible. Now, electron releasing groups. Hello. Electron releasing groups increase the basic strength. Electron withdrawing group decrease the basic strength. Electron releasing groups like OCH3, CH3 increase the basic strength. Electron withdrawing groups like NO2, SO3, SCOH, decrease basic strength. Arranged, obviously secondary is more basic than primary because tertiary is not given. Okay, great. So aliphatic secondary amine is more basic than primary amine, which in turn more basic than ammonia. Ammonia is more basic than aromatic primary amine. So aromatic primary amine is least basic, reason being lone pair is involved in conjugation. Alkylation we have done before. Acylation, just add CO group. See, amine when react with acid chloride, lone pair attack on CO group, we get this product because lone pair when it attached to carbon, nitrogen gets positive charge, and then ultimately Cl negative is removed along with H plus. So we get N-ethylethinamide is H and Cl, they are removed. Here again H and this whole group is removed. Again H and Cl. So we get these products, that is acylation. Carbyl amine reaction, very, very important. It is a test for primary amines. When aliphatic or aromatic primary amine react with chloroform in the presence of KOH, we get alkyl isocyanide, which has foul smell. This foul smelling substance, and that's why it can be easily seen that primary amine is there. If with methyl, with the chloroform and KOH, it gives foul smell, any amine, that is a primary amine. Secondary and tertiary amines do not show this reaction. This is called carbyl amine reaction or isocyanide test, and it is used as a test for primary amines. Reaction with nitrous acid. So with NaNO2HCl, primary amine give first diazonium salt, but it is highly unstable. Diazonium salt of aliphatic amine is highly unstable, and it reacts with water to give alcohol as the main product. It is like this: RNH2 RNH2 HONO. So it is like this: ROH and 2 and H2. But with aromatic primary amine, this is called diazotization reaction. In diazotization reaction, aromatic primary amine give diazonium salt, which is stable at 273 to 278 Kelvin temperature, along with NaCl and water. Secondary and tertiary amines, they also react with nitrous acid in a different manner, and that is not covered by NCERT. But if you wish to do it, give nitroso in secondary, NHOH secondary is, and N double bond O in tertiary, like this: R2NH, and we have HONO, right? Removed R2N NO. Okay. Hindrance reagent test, that is also very, very important. It is test for primary, secondary, and tertiary amine. With primary amine, we get the product which is soluble in what? Alkyl. Why? Because there is still one H. So primary amine react with Hindrance reagent. And what is Hindrance reagent? Benzene sulfuryl chloride. And the product formed is soluble in alkyl. Because hydrogen attached to nitrogen in sulfonamide is strongly acidic. The presence of strong withdrawing group. So it is soluble in alkyl. The secondary, Hindrance reagent react with secondary amine, but product form is insoluble in alkyl because there is no acidic group. That's why it is insoluble in alkyl. Tertiary amine do not react. Reason being, there is no NH available, no hydrogen available on tertiary amine. That's hello. Yes, beta. Primary, secondary, and tertiary. Primary amine react with Hindrance reagent. Product formed is soluble in alkyl. Why? Because there is one H, which is strongly acidic. Hydrogen attached to nitrogen, and in turn attached to electron withdrawing group. That's why it is soluble in alkyl. Secondary case, product Hindrance reagent react with secondary amine because there is one NH, but in product there is no H, no acidic hydrogen. That's why it is insoluble in alkyl. In tertiary do not react with benzene sulfonamide chloride. Why? Because there is no hydrogen available. Okay, that's the case. Now, electrophilic substitution reaction. Now, when we see aniline, what is the nature of NH2? Yes, beta. What is the nature of NH2? NH2 has plus R effect or minus R effect? Fast, reply fast. What is the effect of NH2? NH2, hello, plus R or minus R? Yes, beta. It has plus R effect. NH2 has plus R effect, and that's why it is electron releasing group. And you know, resonance takes place at ortho and para, so it releases electron at ortho and para, means electron density increases at ortho and para. Therefore, it is ortho para directing group. Ortho para directing. So see, bromination, bromine water. So all the three positions, because NH2 is highly activating group, so all the three positions are occupied. For 6-tribromo aniline. To stop at 1, what we do? We deactivate NH2. Now to deactivate NH2, what we do? We treat it with acetic anhydride or acetyl chloride. We get N-acyl and phenylethylamide. Okay. And phenylethylamide, and that's why lone pair, there is cross conjugation of lone pair. Lone pair is less available for donation, and that's why only bromination takes place at para position. And then on further hydrolysis, we get 4-bromo-aniline. What happened by using COCH3? The lone pair is involved in conjugation with COCH3. So it is less available for donation to the benzene ring. So lone pair of electron or nitrogen is less available for donation to benzene ring. So activating effect जो है, it is less than amino group. Okay. Next, nitration. So see, on nitration of aniline, we get ortho and para, and surprisingly, meta is the product formed with 47%. We have studied just now, we have learned that NH2 has ortho para directing influence. So obviously, ortho and para are the products formed. Para may be the major, and ortho should be the minor. But here, in this case, when nitration takes place with nitric acid and H2SO4, we get meta product, 47% meta product. This is very close to para product. Why is it so? Keep in mind, reason is aniline in strongly acidic medium give anilinium ion. And you know this anilinium group, it is electron withdrawing group. It is electron withdrawing group which direct the electrophile to meta position. That's why we get meta product. To get only para, again we protect the NH2 by acetic anhydride, acetaldehyde is formed, and then nitration takes place at para only. And further hydrolysis give para-nitro-aniline. Sulfonation. So you know aniline is acid, a base. H2SO4 is acid. First acid-base reaction takes place. We get anilinium hydrogen sulfate. And then 453 to 473, we get sulfonilic acid. This is basic group. This is acidic group. That is called dipolar ion. So one of the H plus from SO3H is attached to NH2, So we get this nitriene, or we call it as dipolar ion. So we get this dipolar ion, or we call it as sulfonamic acid. Aniline does not undergo Friedel-Crafts reactions. Why is it so? Because in Friedel-Crafts reactions, we use alkyl halide along with AlCl3 and acyl chloride along with AlCl3 anhydrous. So this anhydrous AlCl3 is a Lewis acid as well. So it will get attached to NH2, form a coordinate bond with it, NH2 AlCl3, and therefore lone nitrogen of aniline acquire positive charge, and therefore it acts as a strongly deactivating group. Instead of catalyst, AlCl3 act as a poison for aniline. Therefore, further reaction does not take place. So keep in mind, aniline does not undergo Friedel-Crafts reactions to salt formation with AlCl3. Okay. The reactions we will come to that later on. Now, Diazonium salt. Just now I told you that primary aliphatic amines, they can form highly unstable alkyl diazonium salts, and we get alcohol as the end product. But primary aromatic amine, they form diazonium salt which are stable for a short time at low temperature. Low temperature of the order of 273 to 278 Kelvin. It is stable. Aromatic primary means they form arene diazonium salt and stable for a short time in a solution at low temperature, and the order is 273 to 278, and stability is due to resonance. See, it acquires En double bond, and due to resonance it is somewhat stable, but it is a very good leaving group. So see, aniline when react with NaNO2HCl at 273 to 278 Kelvin, we get Diazonium salt, and this is called, reaction is called diazotization reaction. And this generally stored, this diazonium salt not able to be stored because it is highly unstable, so it is used immediately after its preparation. So it is a colorless crystalline solid, readily soluble in water, stable in cold, but reacts with water when warm. It decomposes easily in the dry state. Benzene diazonium fluoroborate is water insoluble. So now diazonium reactions of diazonium salt. These reactions we have done in aryl halides. Diazonium salt when react with cuprous chloride in HCl, cuprous bromide in HBr, cuprous cyanide with KCN, we get chlorobenzene, bromobenzene, cyanobenzene. But with copper salt, copper metal in HCl, copper metal with HBr, we get chlorobenzene, bromobenzene. That is called Getterman reaction. And with cuprous chloride, we call them as Sandmeyer reaction. But the yield of Sandmeyer reaction is better than Getterman reaction, because in Sandmeyer reaction we use cuprous chloride, that's HCl, cuprous bromide with HBr, and cuprous cyanide with KCl. So we get chlorobenzene, bromobenzene, cyanobenzene. And with copper metal and HCl, or copper metal and HBr, again we get chlorobenzene, bromobenzene. Because with cuprous salts, the reaction is called Sandmeyer reaction, and with copper metal, we call it as Caterman reaction. But yield of Sandmeyer reaction is better than Caterman reaction. Now next is iodide. Just treated with potassium iodide, we get iodobenzene. With HBF4 to form fluorobenzene, we treated with HBF4, we get fluoroborates Diazonium salt. Then on further heating, we get fluorobenzene. To replace with hydrogen, we treat it with H3PO2 H2O or ethanol. So we get benzene as the product. Ethanol or hypophosphorus acid. Replacement with hydroxyl group, just treated with water and rise temperature up to 283. Instead of 273 to 278, just raise few Kelvin, that is up to 283. Salt gets hydrolyzed to phenol. With fluoroboric acid, again we get the same product. If we heat it, we get fluorobenzene, and if we treat it with NaNO2 and copper, we get nitrobenzene with NaNO2 and copper. Coupling reaction. Last one is coupling reaction. So in coupling reaction, say diazonium salt is treated with phenol or aniline. So if phenol is used, phenol is acid, so we use basic medium, and with aniline is a base, so we use acidic medium, and ultimately we get the azodides. Para hydroxyazobenzene, just O orange, and second is yellow. Orange dye and yellow dye we get. Para aminoazobenzene, that is yellow dye, and para hydroxyazobenzene, that is orange dye. See, this is diazonium salt. And this is the electrophile. So this electrophile will attack with respect to OH at ortho and para, but para is the favorable position, being less hindered, because this is bulky electrophile and that will attach to para. So we get para hydroxyazobenzene, para aminoazobenzene, and this is called coupling reaction. This is also electrophilic substitution reaction. These are coupling reaction, and this group is called azo group. That's why they are azodides. That's all about diazonium salt. So you know what is the importance of diazonium salt? It is clearly diazonium salts are very good intermediates for the introduction of fluorine, chlorine, bromine, iodine, cyanide, OH, NO2 group into aromatic ring. Aryl fluorides and iodides cannot be prepared by direct halogenation, but here we can use simply Ki and then HBF4 on heating. We get aryl fluoride and iodide. Cyano group cannot be introduced by nucleophilic solution of chlorine in chlorobenzene, but can be easily prepared from diazonium salt. Just we have seen that chloroben, just we have diazonium salt, we use UCN, KCN, so we get cyanobenzene. So replacement of diazo group by other groups is helpful in preparing those substituted aromatic compounds. Cannot be prepared by direct substitution in benzene or substituted benzene. So that's all about this lecture. See here, CH3 with respect to CH3, there is NO2. You know, NO2 and CH3, and CH3 is electron releasing group. This is electron withdrawing group. So electron releasing group beside the duct. On bromination, bromine is attached at ortho with respect to CH3. So para is blocked. Then with SnHCl, you know, NO2 is converted into NH2. Now on diazotization, this NH2 is converted to N2Cl, H2O and H3PO2 Now this whole thing is replaced by H, and then with the KMnO4 in basic medium. CH3 is replaced by COOH. In this way, 4-nitrotoluene is converted into 2-bromobenzoic acid. Let's convert 3-methyl aniline into 3-nitrotoluene. 3-methyl aniline into 3-nitrotoluene. Obviously, NH2 is replaced by NO2. So, first of all, diazotization. Whenever NH2 is replaced by any other group, just diazotization first. We get Diazonium salt, then with HBF4, we get chloroborate, then with NaNO2 and copper. On heating, we get nitro product. Aniline to 1,3,5-tribromobenzene. So aniline on bromination, when it is undergoing bromination, what we get? 2,4,6-tribromoaniline. Now replace NH2 by H. So first of all, again diazotization, NaNO2HCl at 273 to 278 Kelvin temperature. We get this product. Then with ethanol or H3PO2 plus water, replaced by H. So bromine, 1,3,5-tribromobenzene. That's it. So that's all. Thank you so much. Okay, beta. Any doubt? It's all about amines and diazonium salt. Home और नाम मुझे फिर कैसे? ओके बेटा, बोलो बेटा ओम और जुबी. हाँ जुबी. यस, कोई डाउट? ओके बेटा, तो ये इसके एक्सरसाइज कर लेना पूरा है. Thank you so much to all of you. Yes, beta. Thank you so much, all of you, to be with me in this one shot of amines chapter of class 12th. Do share with your friends. Do subscribe to my channel. Share with your friends so that all will be benefited by my efforts. And help me to appreciate my efforts. Just like the video. And same time, share with your near and dear ones. Okay. Have a nice day. Bye bye.